asking you here for this second part is going to be, why do those properties exist? Are you with me there? So you're going to tell me, all these properties are caused by hydrogen bonds, which is the connection between water molecules. Yes? But what's the connection within the water molecule? Inside. Polar covalent bond. So it's a polar covalent bond. So you have to explain both things. How do I do that? I can even draw a picture. I can put oxygen, hydrogen, hydrogen again. And I can just make a little arrows to show that it's a polar bond. Put a negative sign here, put a positive sign there. And then make another water molecule next to it. Exactly the same. I make a polar covalent bond, make little signs. And I say, because there's a negative sign here, and I make an arrow saying H bond. See? I showed you both things in one drawing. The polar covalent bond and the hydrogen bonds. Now, that's one part. That is explaining the structure of water. The other thing you got to do is you tell me how that structure will go on to help life. Okay? So, tie it to the things you talked about. Let's talk about cohesion. How does this make cohesion? Why is there cohesion? Why does water cohese? Right? Hydrogen bonds between water molecules cause them to do what? Stick together. Why does water stick to other stuff? Polarity of water, right, makes water act like a magnet and it sticks to stuff. Why does water have a high specific heat? Because in order to make the water heat up, why do you have to break? The bonds. Why does water have a high heat of vaporization? Because before it evaporates, what does it have to do? Break the bonds. Why does water is a great solvent? Because it does what to things? Dissociate them. Because it's such a strong magnet that it does what? Splits the ions. Remember we talked about this. Okay? So you are connecting the structure of water, either the hydrogen bonds or the polarity, to explain the properties. You got that? So here's an example here. Done? Alright, put in first back with the name on it. Again, pay attention because I'm going to do this one more time. Right? The structure of water. How does it tie to the function? Okay. Why is it cohesive? Because there are hydrogen bonds between the molecules. Why is it adhesive? Because the polarity of water makes it act like a magnet that sticks to stuff. Right? Why is it high specific heat? Why does it have a high heat of vaporization? Because you need to break those bonds to warm the water up and to make it evaporate. Why is it less dense as a solid? Because the hydrogen bonds lock the solid in position, which make it into a crystal, which makes water actually what? Expand when it solidifies. Everything ties either to the polarity of water or to the hydrogen bonds. Understand? For example, why is water such a great solvent? Because it's so polar that it dissociates the other molecules. Right? Which takes us to the next part. Now, these are the two essays, by the way. One in enzymes, one in water properties. I broke down everything for you. Practice them. Don't come here tomorrow without practicing because you're going to do bad on that if you don't practice. By the way, the 50 multiple choice questions will be worth 20 grades. And then each essay will be worth 5 grades each. So this is a 30 grades test. So become ready for it, right? So, alright. So, by the way, think about it this way. If you kick this test butt, your grade will improve a lot. So please prepare. Okay? Now, on mixtures, I'll tell you what not to worry about. Do not worry about the difference between solvent and solid. I'm not going to ask you that stupid question. Which one is the solid? Which one is the solvent? Only understand, obviously, that water is usually solvent. Also, I'm not going to tell you about the difference between tinctures and aqueous solutions. You have to know aqueous solutions is water, but I'm not going to ask you about that. I will ask you about dissociation. Okay? Which compounds, what kind of bonds does water break? Which bonds does water break? Does water break covalent bonds or ionic bonds? Ionic bonds. Remember that water dissociates ionic bonds because ionic bonds are like magnets, and water is another magnet that gets in the way. So this polar stuff, covalent bonds, water doesn't break those things. It just surrounds those molecules. Remember I did two little water pictures. So I'm going to do it again so you see what I'm talking about. When you put salt in water, that little bond, a magnetic bond that happens between these two things will separate because of water, and that's called dissociation. But when you put sugar in water, sugar is a bunch of things bonded covalent together, like a little ring. That does not dissociate, it doesn't break apart. Instead, water is just going to surround the sugar, attach the polar parts of the molecule. You understand what I'm saying, the difference? Yes? Okay, so make sure, I know there's a question about this. Which bonds does water break better? It's going to be the ionic bonds, not the covalent bonds. Water doesn't break covalent bonds. Instead, it surrounds those molecules. Okay? If they're polar. If the molecule has covalent bonds and they're not polar, what happens? What does water do to it? Pushes it away. What is that called? That's in a test. A molecule that hates water. I'm scared of it. Hydrophobic. Now, what about the molecules which are polar and love water? They're hydrophilic. That is just basic key terms, terminology. As we hit cytology, you got to memorize key terms. You got to make flashcards. You can't be here the day before the test not knowing the key terms. That's the problem. Alright? Alright. I'm not going to ask you about fizz. I'm not going to ask you about hard water versus soft water. I'm not going to ask you about electrolytes versus non-electrolytes, so don't worry about that too much. I'm not really going to ask you about how to increase dissolving rate by stirring, heating, or crushing. We're not going to worry about that. I'm not going to ask you about solubility or concentration, saturated, unsaturated, supersaturated. I want you to know that, but it's not going to be the test, I don't think. I'm not going to ask you about freezing point depletion and boiling point innovation, although you need to know what that is. Alright, for the test, for the primary year. And I'm also not, but I will ask you, what does water do to polar stuff versus non-polar stuff? So what does water do to polar stuff? Yes, so it dissolves that, right? Dissolves that. What does water do to non-polar stuff?
It separates it.
Pushes it away, right? So make sure you remember that. Just so you know, if the concentration is higher than your solubility, you have supersaturated. If it's the same, you have saturated. If it's less, it's unsaturated. We talked about this already. Now, the last topic, pH. There are quite a few questions on pH, and there's a few. Here's what you need to know about this one. What is the pH of water? 7. Why? It has the same amount of hydrogen ions and hydroxide ions. When you put a strong acid, what happens to that acid? It almost completely dissociates. Sure, that's a question. What makes hydrochloric acid so strong? It almost completely dissociates. What makes sodium hydroxide so strong? Such a strong alkaline base? Because it almost completely dissociates. You got that? Alright, now, we also talked about the idea of what happens when you put a base in something that's... What are you going to happen to pH when you throw a base in there? You did it yesterday. What happens to a base? If you throw a base, what happens to pH? Goes up or down? You add a base, what happens to pH? What is the range for bases? You didn't know it. 7 to 14. So if you put a base, what happens to pH?
It
Goes up. If you put an acid, what happens to pH? So the question says, this scientist came through and put a bunch of sodium hydroxide. That's a base. Hydroxide. OH means base. He puts a bunch of sodium hydroxide. What happens to pH? Goes down. Here comes a scientist. He adds a bunch of hydrochloric acid. What happens to pH? Goes down. Make sure base, raise the pH, acids, lower the pH. Right? Okay. Another thing you need to know about pH. Okay? The idea of buffers. Alright? Some classes didn't cover that very well. But basically the idea is, if you have a buffer, the pH will not change. Alright? So basically, I throw acid in there, it's supposed to do what to pH? Lower it. But the buffer traps the hydrogen ions before they have a chance to increase the pH. And so, what does the buffer do? It's a chemical that accepts the hydrogen ions and prevents the solution from doing what? Change the pH. But the same chemical, if you put a base, it donates hydrogen ions, and so to balance out the base. So buffers can either control the acidity or the alkalinity. That's what's so beautiful about it. But that's very important for life because you have to maintain that pH so your enzymes will work. Right? So your blood, your cells, always